Okay, I guess it's working. And my voice is now loud and booming. So I'm here to talk about Polymer. Because of course Google can't just do one of anything. They have another web framework that you may or may not have heard of called Polymer. But first a little bit about who am I. I'm a senior software engineer at Notch 8. We're a consultancy. We focus mostly on Ruby on Rails, but do lots of things with JavaScript and whatever around the web apps. So first, enough of us who have been around the block have probably played with other JavaScript frameworks, so I thought I'd start with a few comparisons. Polymer is very component-based. Very much like React, you are going to build components. Angular and Ember are kind of moving that way, but I feel like Polymer fits more like React. It provides more of a view layer, and you can provide the rest. It's not like Ember where it provides everything in the kitchen sink. You can do it how you want, but also there are plenty of elements provided by Google and others in the community that you can use to build whatever kind of app you want. It also provides the usual things that these frameworks provide, data binding and abstraction around events. But the important thing is what makes it different. I believe the Polymer team at Google is actually embedded inside the Chrome team, so their focus is on new features in the browser, which is why Polymer is based around web components, which are actually a standard that you can use in the browser without using Polymer, that allow you to create your own elements and your own components with standard DOM APIs. Nothing super special other than it's all brand new. Some of the new technologies that Polymer relies on are things like importing HTML, which can be very handy because you can import anything in that new HTML that you could put in regular HTML. So you can import CSS and new JavaScript that way, and Polymer relies on that heavily. It also provides new CSS features. These are things like variables, mix-ins, as well as special new selectors that are designed specifically for web components. So I'd like to dig in a little bit on just the web component elements, and it's technically 4 specifications from the W3C. The first one is custom elements, which simply is a way of registering a new element. So if you want the element xfoo, you can create that and register it with the DOM. So when you use that in your HTML, the DOM will know what that means. It also lets you register the lifecycle events for when the element is created, when it's registered, and when it's removed from the DOM. You may already be familiar with the template element. It's actually the one of these that's been around the longest and is supported in most browsers. It essentially allows you to create a piece of HTML that's parsed by the browser but not rendered, and it provides a simple API for sucking that HTML out and inserting it wherever you want. The shadow DOM is the big deal with web components. It allows you to encapsulate styles and everything inside of an element so that the CSS inside a web component does not affect any of the CSS outside. This is particularly important the bigger your app grows. Keeping CSS in line and not affecting other parts of your app can become very difficult the larger your app grows. So being able to constrain that so the CSS only affects the things inside a particular component can be very handy. As well as the imports that I discussed a little bit before, being able just to import anything you can put in an HTML document. So here's some of the features. You can do one-way and two-way data binding. I'll explain more about why it has both ways when I do some demonstration. It has an event handling system. The most important thing about this is it'll handle touch events for you. If you read the specification for some of the touch events, there are a lot to handle, and Polymer boils it down to 4, where you can do up and down for when you touch, when it's just a tap, as well as a drag. So it makes handling all that very easy, and it makes making a mobile website with Polymer all that much better. You have the ability to observe properties and compute properties, and it also provides a nice selector. One thing that the shadow DOM does is that is an encapsulated bit of DOM as well as CSS. So you have to know you're selecting into the shadow DOM to actually get to those elements, because they are hidden from the rest of the DOM. Polymer abstracts this from you and makes it so you can easily know you're always getting the elements you want to access to change things. Also, Polymer works in a very object-oriented fashion. If you're familiar with object-oriented JavaScript, that is exactly how Polymer works. So it has mix-ins that are called behaviors. So if a lot of components do a lot of the same things, like input elements and the like, you can have behaviors that are mixed into and shared across all those components. And my favorite part of Polymer is all the elements that are out there to build stuff with it. So Polymer itself is nice and small, much like React is, but there's all this stuff out there in the ecosystem to help you with routing, material design, Ajax, all sorts of stuff from Google, because Google makes it, PubSub, Bluetooth. It abstracts service workers and all sorts of new things. In particular, you'll see a lot of these things have to do with browser features. That same emphasis I started with, that these are new features in the browser that the Chrome team is highlighting, like Bluetooth and service workers. And finally, before we get to some code, there is a full set of tools around Polymer. It can come with a full setup test suite for testing in Mocha with Selenium. There's a CLI for generating projects, build tools. Vulcanize can take all your components and build them into one HTML file. And CRISPR is nice because it takes that big HTML file and splits out the CSS and JavaScript into individual files if that's what you want. There's part of that giant list of components you can use. There are components to help you document your components as well as demo them, as well as there's a linter, of course. So now let's look at some code. So first, here is the super basic app that the CLI generates for you. So here's my Pokédex. This is the little app I built for us. It lets us search for whatever Pokemon we want and returns details of that Pokemon. So I know Pokemon 9 is one of my favorite. Takes it a second to return. So it goes out to the web using the free Poke API and returns information on Blastoise. So now I'm going to take you in to look at this code and see what's going on to make this happen. So first I'll show you in my view 3. So all this starts with there. Let's make this a lot bigger. So first you can see I used an HTML import. So it's just using relation import and a normal link tag, and then the usual path to my element, and that's all it took to import it. And then that's all it took to instantiate it, and Polymer knows to put it there. So let's take a look at what my Pokédex looks like. So at the top I import lots of things that I'm going to use, and then it's all encapsulated in this DOM modules element. That's just kind of the boundary layer for my component. And its core, it's made up of a template tag, which is me saying this is the HTML I want inserted into my component. and a script tag with the Polymer constructor. So a Polymer element is created by passing an object literal to this constructor that goes through and then does all the work of registering my component with the DOM, as well as adding all my properties to that object so I can use it. So here I said, this is my Pokedex. So the DOM knows that when I use that as a tag, it will insert this element. So I have declared properties. These properties are the same as attributes on other elements. So I could either pass these in and back in the other page, this one. I could add these here if I wanted to start with a different search. If I were to save that and restart this, see it's already started with 7 because I passed that into my component. And here I'm showing some of the data binding. That same trick you've probably all seen in every Angular demo. And that is simply done by using mustache-like syntax. So these double curly braces, as you see in most mustache templates, is how you insert variables. And so it knows that I have a property called search, and it will insert it there. But here you see another custom element because there is no paper input that exists in the regular DOM. This is one of those components that Google has made for us. This one is for material design. That's why it says paper in front. So because I have bound with double curly braces search to this, that double curly braces is a two-way bind. So it's very useful with inputs where I can say always update this variable for me. And so when it updates inside that component, it will reflect out to the component I'm using it from. Here is the other form. This is with square brackets. This is saying it is bound in one direction. So I am passing this variable into this Pokemon card component, but I am not receiving it. Like if Pokemon card changes the response variable in its Pokemon property, it will not, my Pokedex component will not receive that because it is only bound one way. So it is most efficient to use one-way binding because Polymer then doesn't have to set up as many things to track that binding in both directions. This I think is pretty unique for Polymer, where I am doing Ajax declaratively in a element. So this iron Ajax is again one of the elements provided by Google, and I give it a URL. I tell it that it's going to receive JSON and tell it to put whatever it receives into this response variable, and it does that. And if I pass auto as a parameter, it does that automatically without me having to call a method on that element. But just to prove that these are just elements that you can call methods on, just as if you were to use jQuery to select an element and call something, or use getElementById to get a form field and call .value on it to get its value. Down here, this .request Pokemon, I told you Polymer will select things and make it easy to select inside the shadow DOM. It also does that for you in automatic fashion. Because I set the ID here to request Pokemon, I have a request Pokemon value on this $, and that is an automatic reference to that element. I don't have to search for it by that ID, it's just already there. And so I can call to have it generate a new request, which is the method on that component, a custom method, for it to then fire off and make the request. Here is an example of setting up some of that event abstraction. So search box is what I labeled the ID of my paper input. So again, Polymer already knows that. It knows it has an element with the ID of search box. So I say when search box receives a key up event, fire this method. So it search for my evaluate search method and fires that off. So if the enter key is hit, it will go find another Pokemon. So if I were to search, because I'm too lazy to type in their names, it'll go find Mewtwo for me. Now I wanted to show you some more features, so I made another component, because of course these are always composable. So I made my own Pokemon card element to display each of the Pokemon and their data. That's here. So again, it is set up in the exact same fashion with DOM module, a script tag with Polymer, and a template. And also I used HTML imports to pull in all my dependencies. Here's one other thing to point out. It has many helper components. So you can actually override the functionality of existing DOM components using the is attribute. This is not just a feature of Polymer, this is a feature of web components as well. Or because I say this template is DOM if, it is my custom component DOM if, which just evaluates this. If it's true, it shows it. If it's false, it's not. That's why you don't see an empty box over here if I were to refresh the page. Except it's firing on auto. So then here, I wanted to show why that property is changing. So on the Pokemon property, which you saw me set here, if that is changed, this observer function will fire. So it knows to look for a method called Pokemon Observer, which just coerces Pokemon.name into a Boolean and sets it to that. So I know that if I have a Pokemon and that Pokemon's name is set, it will be able to display this card. The other thing I can do is computed properties. So these, I don't want them firing unless there is a Pokemon and to compute their value off the Pokemon's data. So I'm actually able to provide arguments to these in this string. So I say the name is a computed property and its method is name and it takes a Pokemon. And down here in name, you can see I uppercase the first letter so that's all displayed nicely and put it together. And so I'm able to compute properties from other properties or take a complex object and boil it down to simple properties I want to show in my view. And then as you can see here, I use mostly one-way binding because I don't need the update from these values. And that is much of the basic fanciness of Polymer, along with being able to show you all the tricks that some of these Google elements can provide, because I didn't have to style this element with the fancy blue bar or anything like that, or make the Pokemon card look like a material design card. That just comes for free and I can use the elements. And this whole my app bit is scaffolded out by the CLI to show you exactly what a Polymer app could look like and should be built. One bit about that I wanted to show before I wrap this up is here in my app. Down here at the bottom. So each of these pages in my app is being loaded dynamically. I don't have to load all of my elements up front and incur that heavy cost. So this is a different way of achieving part of progressive web apps than say React, where you try to render your JavaScript app on the server so that you can just give HTML to the browser and it starts real fast. In Polymer, you can pass down just the elements you want to render that page. And as you go to other pages or other parts of your app, I can use import href, which then uses the HTML imports to then pull in those elements that I want when I need them, and I don't have to pull it all in at once. And also it's scaffolded out so that in production, it generates a service worker automatically. So when you hit the first page, it automatically, after that loads, goes out and requests all your other elements in the background. And so the response time is still just as fast when you go to the other pages because they're already loaded and cached in the service worker. And that just comes for free with how they've set up the app in the CLI. So lots of cool tricks that Google has put together to make Polymer an awesome solution for front-end web apps. At Notch 8, we've used Polymer in 2 projects. One, it was mostly a single-page web app, but where we found the most success for it, we were actually able just to insert bits of higher functionality with simple components into a standard CRUD Rails app, where they needed a fancy uploader, or they needed a really fancy data table. We were able to encapsulate all that functionality into Polymer components and just put data table and insert how it's supposed to get its data. And then that just works. And that's all encapsulated and separate in its component. And it's been rather nice to work with. So that's my talk on Polymer. Again, I'm Stephen McFarlane. If you want to talk about other things with me than cool JavaScript, my really cute daughter and iPhone photography is something I'm into. So thank you.
Awesome.